we're going to look at average atomic mass. Okay? Alrighty. So we're going to look at average atomic mass. Okay? Now before we jump into the calculations, let's do some background. Alrighty? Let's say we have carbon, right? We know carbon atomic number is 6, right? Okay? Now, we know what a definition of an isotope is, right? Okay? Isotopes are atoms that have the same, okay, atomic number. Okay, remember that the atomic number means the number of protons, right? Same number of protons, okay? Because protons give identity, but a different number of neutrons, okay? And now, since you have a different number of neutrons, your mass number, okay, will be different. Okay, so they have the same number of protons, but because they have a different number of neutrons, their mass number will be different. And remember, right, the mass number is made up of what? The protons and neutrons, okay? So what could happen, guys? You could have the same atomic number in the bottom right here, alrighty, atomic number, but you could have carbon 12, carbon with mass number 13, and carbon with mass number 14. And earth science people, carbon 14 should be familiar to you, right? Okay, dating and so on, and carbon dating of previous living material. Yes, all right, so we're moving on. Now, there's something called the average atomic mass that you can be asked to calculate, right? And it's really and truly not that bad. So when we're calculating the average atomic mass, right, we are using the relative abundances, right, of all, okay, emphasis on all the naturally occurring isotopes. Okay, alrighty, bam. So that's what we do. And what's going to happen, ladies and gentlemen, they will give you the actual isotopes, and they will give you the masses of them, and they will give you the percentages of them, right? And they always ask you, okay, what's the average atomic mass of these guys right here, based on the information they give you. So I made up some values, okay? Alrighty. So we have X, right? Some element X. And let's say it has a mass of 36. Mass number 36, right? We have this isotope of X, same number of protons, same X, but that's mass of this guy is 34. So we have two isotopes of X, okay? Now, let's say one of them is in the percentage of 80%, all right? The relative abundance of 80%, and the other one is a relative abundance of 20%, okay? There's 3 simple steps you're gonna use to calculate, okay, the average atomic mass of this guy. Let's move over here to get some more space. So what's the first one? Okay, we did this in class, alrighty, is the first step. Number 1 is to change the percent to a decimal. Alrighty, change the percent to decimal. Step number 2 is to multiply the corresponding decimals and masses. Alrighty? So we're going to go over this in a second. So point number 1, change the percent to decimal. Point number 2 is multiply the corresponding decimals and masses. And step number 3 is to add them all up. All right, right, so 3 very, very simple steps. So let's do that right now, okay? So, x36, 80%, you're gonna have 36, right? But instead of times 80%, right, you're gonna have it by 0.80. Because how do you get 80% to be a decimal? You divide by 100, right? So simple is gonna be 2 places to the left, right? Done, okay? x34, right? 20% of it, you got your 34, that's your mass, times this relative abundance, 20% in decimal form, 2 places to the left, the decimal, or, okay, 1, 2, or you can divide by 100, either or, all right? You'll get 0.20. So that's step one, number 1 right there. We just changed percentage to decimals. Take a breath. Step number 2, multiply the corresponding decimals and the masses. So I did it already, calculated already. So I got 0.8, okay, times 36. That's equal to 28.8. Now guys, do me a favor, get a calculator and calculate to see to make sure, this is correct, all right? But follow the steps, follow the principle, no problem. And 34 times 0.20 gives me 6.8, okay? All right, so that's step number 2. The third step is here, we just add them all up. So we got 2 guys to add up here, 28.8 plus the 6.8, and that's gonna be our final answer, people. All right, done. So the final answer I got was 35.6, okay? Now you should be able to ask yourself, does this answer make sense, okay? Now, notice, right, we have 80% of 36 and only 20% of 34. So you're thinking in your minds, right, who's dominating, who's more? We have more of 36, right? So your answer should be sort of kind of closer to 36 than 34. So you check your answer out, and this is very much close to much more closer to 36 than it is to 34. So it makes sense. We're on the right track. You're done. All right, guys. It's a nice simple video. Average atomic mass. Very simple. Take care.